Hello everyone, it's me, Felipe Lima from Lion Tech. In this brand new episode of September 2025, I'm going to be talking about the different types of engineering, how they affect today's technology, and how they will affect the technology of the future. So first, before we go into the different types of technology, we gotta discuss what is engineering. So at least to me, engineering is using maths and science to find creative solutions to various problems. For example, back in the days, people couldn't cross long rivers without boats. So what they did, they used math and science to create bridges, and that's what we use today to traverse long bodies of water with cars and other types of vehicles. So essentially, engineering is just problem solving using logic by using the means of math and science to solve those problems. So now we're gonna start talking about the different types of engineering. So let's start with mechanical engineering.
So, in my opinion, mechanical engineering is kind of considered the godfather of engineering because it's used in like by so many other engineerings. For example, aerospace engineering could be considered a subtype of mechanical engineering. But what mechanical engineering actually is? It basically is the deals with machines, motion, and energy. So basically, making things that move. So cars, planes, drones. Those are one of the main things that they do. They design, but they also build those, and all of those usually use some type of fuel, some type of something to use energy. So maybe electrical energy, or like gas, as a fun fact about mechanical engineering is that they actually helped design the Mars rover, which is on another planet. So this can like also shows how diverse mechanical engineering really is and how useful it is in our day-to-day lives. And I think for the future, it's gonna help us, especially on the transportation side of things. I think we're gonna get some very interesting transportation types from mechanical engineering.
We're going to be talking about computer engineering.
So, civil engineering is about planning, designing, and maintaining the physical structure of society and ensures buildings and structures are safe, sustainable, and efficient for people to use. So, that's kind of basically the definition of civil engineering. Civil engineers are the people that constructs the buildings of cities and bridges. They are basically the foundation of urban society and urban structure. Some areas of work would be structural engineering, like I said, buildings, bridges, etc. They can also work in transportations by building roads, airports. They also work a lot of environmental stuff sometimes, like water treatment and waste, as well as geotechnical soil and foundations. So everything that will benefit like the structure of an urban city and urban community. And we have like they have very impressive examples like bridges, like the Brooklyn Bridge or Golden Gate Bridge, skyscrapers as the Burj Khalifa in Dubai, subway systems, highway and airports are also made by them. So loads of transportation systems are also made by civil engineers. Not only like the roads the vehicles go, but some vehicles are made by them specifically. And a fun fact is the Great Wall of China is one of the earliest examples of large-scale civil engineering.
Last but not the least, we're going to be talking about biomedical engineering.
So, computer engineering could be considered the intersection of electrical engineering and computer science. It's about designing both the physical parts of the computer, called the hardware, but also the software that runs them. So, basically, that's the definition of computer engineering. For a more detailed part, basically, computer engineers not only work on the actual computer itself, by constructing parts like GPUs, CPUs, anyways, anything that can make computers run, but they also build the software itself, like Google Chrome, YouTube, websites, apps, etc. They are very diverse. They could be also very diverse, but they are very focused in this technological field of internet and computers, phones, etc. We have some areas of work will be for the hardware part, so chips, CPUs, GPUs, etc. Embedded systems, which are smaller computers or smaller like controllers, cybersecurity, artificial intelligence, and robotics. A fun fact about computer engineering would be that the first computer, ENIAC, was built in 1945 for the whole room. Today's computers and engineers fits way more power inside your pocket smartphone. So a computer was made in 1945. It was the size of an entire room, maybe an entire bedroom, like your bedroom. Imagine that. Is now much less powerful than the phone you're probably watching this or the computer watching this. So that's really impressive to see how computer engineers really improved our modern day technology.
And now for the fourth type of engineering, we're going to be talking about electrical engineering.
Electrical engineering focuses on electricity, electronics, and electromagnetism. It's about generating, transmitting, and using electrical power, as well as designing systems that control or process those signals. So that's the definition of electrical engineering. But in a more clear way, it's everything about electricity, maybe. It's making things that control electricity. So they use electricity. So wires can be part of electrical engineering. And electrical engineering is kind of the basis for various types of engineering, like computer engineering, which needs electrical engineering because computers run on energy. But it's a little bit more focused to specifically only electricity. So whereas in your home that connect to your lights, etc., not only are the wires constructed by electrical engineers, they plan how to put that uh, also electricity that goes through the entire city. That's all planned by electrical engineers. Also develop the products and systems that use those things like light bulbs, washing machines, fridges. They also help with that because they need to help manage how much electricity each thing needs and control that. That also works for entire cities. So the how electricity works in cities is all built by electrical engineers who also build the products to actually sustain and control those currents. Some areas of work will be power generation, renewable energy, telecommunications, microelectronics, and control systems. And a fun fact: electrical engineers created the microchip, the microchips and power nearly every modern electronic device and laptop to cars. So we can see how diverse electric engineering is and how it influences various other engineering types, especially computer engineering.
Last but not the least, we're going to be talking about biomedical engineering.
Biomedical engineering applies engineering designs to solve medical and healthcare problems. It's about improving patients' care through technology. So biomedical engineering is mixing medicine with engineering, so with technology. So using maths and science to solve medical problems or to help improve healthcare. So that's really the point of medical engineering. We have various examples. For example, we have, as you may be seeing on the screen, doctors now use robots. They can now control robots that can do surgery for them, and that is very helpful, as those robots are more precise than the humans. So it's easier to do more harder surgeries that need really a big precision or in very small parts of the human body. So it will make healthcare more effective and decrease the danger and also decrease human error with having those technologies implemented in medicine. Some areas of work is medical imaging, prosthetics, mechanics, biomaterials, tissue engineering, etc. So constructing the things that doctors can use. So make the healthcare system and healthcare in general better. But doctors can also help create those and use them in hospitals, etc. A fun fact about medical engineers, they helped create wearable devices like fitness trackers and continuous glucose monitors for people with diabetes. So that's a creation made by biomedical engineers.
So in kind of a conclusion, as we can see, engineering is like a very widespan area. So it can go from different places like mechanical engineering, where you build cars, planes, anything that kind of moves. When we can go to some place like biomedical engineering, which works kind of like with doctors to help find solutions for diseases and understanding how like living things work. So I think engineering is a very widespread area, and even if someone doesn't actually work an engineering job, they're still using some engineering ideas in their everyday life like math, science, etc., or in their job or anything, everything in life. I think engineering is one of the most widespread majors and widespread areas of where people can work. And I think it's just really important and kind of constructs what our modern society kind of is like. So that's it, everyone. Thank you very much for watching this brand new episodes of Land Tech. Hope to see you in the next one. Goodbye.